Hello and welcome to Tyler Programming. And today we're going to be tackling this interview question from Cracking the Coding Interview. Implement an algorithm to determine if a string has all unique characters. And then, what if you cannot use an additional data structure? I will present two solutions, the code and the big O notation for using and not using another data structure. Let's get started. All right, whenever you're presented with this question, it's always good to let the interviewer know what you're thinking. In this particular question, it'd be helpful to ask if we're using ASCII or Unicode strings. We're going to assume ASCII 128, but they may say ASCII 256 or do something with Unicode. Let's briefly go over a couple examples of this problem just to make sure we understand. It's pretty straightforward. So if we take a string, which is the combination of characters or letters and numbers or some symbols, we need to make sure that they don't appear more than once in that string. So for instance, we take the word unique. Well, we have a U here, and then we have another U here. So the word unique is actually not unique in the problem we're going after. However, computer, because none of these letters appear more than once, this is a unique string. Now let's go ahead and go over the first two solutions that use other data structures. Okay, so we have several solutions, as I've mentioned, and some of them are brute force, and they might make a little sense just by looking at the code. However, I want to go over the first solution really quick, kind of show you an example of what it means, because just looking at the code might not make as much sense. We're going to be creating a Boolean array of size 128, correlating to ASCII 128. We're going to take the string, we're going to convert each letter or number to the ASCII number. Okay, so for instance, A in dad, which is the string we're going to be looking at, when we convert it to a number or integer value, it happens to be 61. Okay, so I just have a portion of the Boolean array here. Now, in a Boolean array, we set all of the indexes to false to start out with. And then once we convert the character we're looking at, like A, we convert it to an integer value, which is 61. We're going to change that value at that index from false to true. Okay, so then if we happen to hit an A again somewhere else in the word or the string, we're going to come back and see that it's already set to true, so we know that the string is not unique. Let's go over this example, okay? Well, the first one is D. We have the letter D. Well, D, when we convert it to an integer value, is 64. Now, 64 is set to false, so we would erase that and set it to true. And then we see the letter A, that's next. Well, A converts to the value 61. So we take the index 61, change it from false to true. Then we have D again. Well, D converts to 64. Well, we come down here to index 64, we see that it's already set to true. And because of that, we know this is not a unique string. Now we have four different solutions that we're going to go over. Let's go ahead and go over the first two solutions because they let us use other data structures. So the first one I call is unique characters. All right, we just take in a string for all these methods. Now, because we're only using the first 128 characters of ASCII, we can set up a base case where if the string.length is greater than 128, just return false. Because at that point, we know that there's 129, for example, they're not all unique. There has to be a duplicate somewhere. And then we go ahead and set our Boolean array to size 128. And then we have a for loop here. So it just goes from I equals 0 all the way to the string.length. And then we get the value of that character. If the Boolean array, or which we called set, already has something at that index, so if it's already set to true, then we just go ahead and return false. So otherwise, we're going to set the index, which is the value of that character, we're going to set it to true. All right, so the first time through, nothing can happen, right? We just go ahead and set the value equals true. And then after the first time, we need to check to see if the value at that character is already set to true in the corresponding index of the Boolean array. And if it is, and if it's already set to true, we know that we've already encountered this character. So we keep doing this until we go through all of the characters in the string. And then if we haven't returned false, then we end it and return true. Okay, so if we return true, that means the string does have all unique characters. Now, the time complexity for this is big O of n, where n is the length of the string. Okay, because of the for loop here, We say for int I equals 0, I is less than the string.length. Well, string.length is n because it's a variable size, depends on the length of the string. And because of that, it's not constant, we say the time complexity is big O of n. Now the space complexity is only big O of 1 because the Boolean array is constant in size. Okay, if the Boolean array was based on the length of the string, then the space complexity would also be big O of n. However, it's always 128 characters in size. However, it always has a size of 128. Now, we could argue that the time complexity could be big O of 1, since the for loop can never iterate more than 128 times. It's always the same regardless of the size of the string. Because if the string was greater than 128, then we just go ahead and return false in the beginning and we never even come to the for loop. Okay. So if you were to mention this in the interview, I'm sure that they would like to know both sides of the time complexity that you're talking about. But if you just say this is big O of n because it's a for loop, it's based on the size of the string, perfectly fine. Now let's go over the second solution using a set. Okay, this is a little bit more straightforward and a little easier to understand. Since we're using a set, we just first create the set character, character set equals new hash set. Then we have a for loop that goes through the length of the string. And at each iteration, we add that character to the character set. And the thing with the set, it only carries unique items. So if we try to add something else that already exists in the set, it won't add it. It'll just skip it. Which leads us to, if character set.size does not equal s.length, return false. Okay, so if everything is unique, the character set is going to be equal to the length of the string. However, if we try to add duplicates, remember, it just skips it and doesn't add it. So we're not adding that character as part of the string into the set. So that means the set will be less than the length of the string, so they won't be equal. So we're just going to go and return false. Otherwise, return true. Now, with the set, its size will be based on how many characters there are in the string. Well, the time complexity here is big O of m on average, where m is the size of the string. Now let's go to the first solution without using another data structure. Okay, so this time we're not using another data structure, right? But the first thing we're going to do is check if the string length is greater than 128. If it is, just return false, okay? And because we're not using another data structure, this is really the brute force method. And in an interview, it's okay if you explain the brute force method. It's perfectly fine. You just need to let them know what you're thinking and go through the process, okay? We have a nested for loop. So the first thing is a for int I equals 0, I is less than the length of the string. And then for int j equals 0, j is less than the length of the string. Okay, so now we have it set up. And all we say is if string.character at I is equal to string.character at j, return false. So the outer loop is going to be at index 0, and the inner loop is just going to go through every index or every other character in the string. Okay, then once we're done that, on the outer loop, we'll go to the next character in the string and then compare it against every other one in the string, okay? So this is why it's a nested for loop. Now, because this is a brute force method and it's a nested loop that's iterating over a string, the time complexity is big O of n squared, which isn't really great at all. But it does have big O of 1 space since we're not using another data structure. Now let's go over the last solution, which will be a little bit better without still using another data structure. All right, so this one, we call it isUnique sorting string because we have some sorting involved. So again, the first thing we do is check if the length of the string is greater than 128. If it is, return false. The next thing we do is we want to convert the string to a character array. Okay, so we say char with the brackets content equals s.to character array. So we're just converting the string into a character array. Now we're doing arrays.parallel sort of that character array. Now what is parallel sort? Well, after Java 1.8 and above, the arrays also has just a dot sort method, but the parallel sort is just a version of the merge sort, which is a great sorting algorithm. Okay, so after we sort all the characters in the array, then we just linearly search through the character array. For int I equals 0, I is less than the content dot length minus 1. Okay, all we're doing is checking the adjacent characters in this array. So if content of I is equal to content of I plus 1, so we're checking the very first character against the second one. And then the next iteration will be the second character in the array, compare it against the third one, and we keep doing that all the way to the end. And if at any point they're equal to each other, we just return false, saying that it's not unique. Otherwise, we'll return true. Now, since we sorted first and then just had a linear search with a single for loop, this makes the time complexity big O of n log n. Okay, not big O of n squared. Big O of n log n is because of the sorting algorithm. The for loop is just big O of n. However, because of the sorting algorithm being big O of n times log n, we have this. Depending on the language's default sorting algorithm API, it could take up extra space. I'm not sure about that with other languages. But generally, sorting can give you a better time complexity. Well, I hope this has helped you understand the solutions that you could use in your interview, as well as understanding the time complexities for each of these solutions. It's always good and helpful to start out with a brute force solution so that the interviewer knows what you're thinking, and then move on from there. You don't always have to let them know and spell out the code for them for some of these solutions. Just let them know the process of what you're doing. Well, I hope this has been helpful, and I'll see you next video.